Hello. Now I shall give a brief analysis of the Bitonic sorting network. So, into the previous video, we have discussed about the generation of the Bitonic sequence with respect to an unordered input. By the meaning of unordered input, I meant to say that the nodes are that that the elements are jumbled. That we cannot be able to say that these elements are either into the ascending order or descending order. For example, here there is the element 10, which is the first element. The second element is greater than 10, but then the next element is lesser than 5. Then the next element is greater than 9. So here this is a example Bitonic sequence. So here this is the example. Here we have constructed a Bitonic sequence with respect to this Bitonic, with respect to this input data. Now, one thing that I want to mention, that in order to generate a Bitonic sequence with respect to some unordered data, we have primarily took on two elements initially, and then check whether which of the element is greater, uh, and then arrange them into the ascending order with respect to these two values by the increasing comparator. Similarly, the next two elements are being compared with the decreasing comparator, and they are being arranged into the decreasing order. Now, these four inputs, these four elements or the intermediate inputs are being given as an input towards the stage two, towards the stage two. Here, such that the 10 is being compared with the 9, and 20 is being compared with the 5 with respect to the increasing comparators, and whatever the intermediate output that's been obtained is further being compared in a continuous manner uh, in between the values, such that the final output with respect to this Bitonic merging operation into the intermediate sequence generates an output into the four element ascending order. Now similarly, you can be able to observe that these are the that with respect to the first stage, the two elements are 3, 8, which are being compared with an increasing comparator, and then 3, 8 output is being generated because it is already into the ascending order. Then for the next two elements, 12 and 14, uh, they are being compared with the decreasing comparator, and these 14 and 12 is values being generated. Now in this way, the every two values are being combined after the completion of the stage one with the next two values, such that in this way these four values has become a binary sequence. Now our requirement is that we have to that that with respect to every stage we have to pass some Bitonic sequence to the other stage, such that that monotonically increasing and the decreasing uh, subsequences will be converted into the sorting order. Similarly at here, this 3, 8 and 14, 12 has been taken, and then they are being compared with the decreasing comparator, and they are being arranged into the descending order. The reason is that the first four elements are being converted into the monotonically increasing order or the ascending order by the increasing comparators, and the Bitonic sequence has the requirement that the that it must have two that it should have two subsequences, in which first of the subsequence should be in the monotonically increasing order, while the second subsequence should be in the monotonically decreasing order. So in this way, now these the first four values which are in the ascending order and the next four values into the descending order are being given. These eight values are being given towards the stage three, such that with respect to the increasing comparators, they are being arranged into the ascending order with respect to these eight values, and similarly for the next eight values, they are being arranged into the descending order. Now now uh, now now we can observe that with the help of this Bitonic sequence, with the help of this two element Bitonic sequence, and the 2 element Bitonic sequence, we have generated a 4 element Bitonic sequence in which the first 2 elements in the ascending order and the next 2 elements into the descending order. Then with the help of these 4 elements into after this intermediate input and the next 4 elements after this intermediate input, we have generated the 8 element intermediate output in which the first 4 elements are into the monotonically increasing order and the next 4 elements are into the monotonically decreasing order. Now these 8 values are being given uh, are, be, are being given to the towards the stage 3, and the next 8 elements are being given towards the stage 3, such that a complete list is being generated after the stage 3 into the monotonically increasing order of the first subsequence, and the second and the second subsequence is having the monotonically decreasing subsequence. So in this way, a Bitonic sequence is being generated. So uh, so so if we have some unordered data, so it should be first converted into the Bitonic sequences uh, by by first comparing the two values, then uh, then generating the two elements output, and then combining with the next 2 element output. Then in this way we will be having the four elements output, and then they are being combined with the rest of the sequences. In this way we can be able to generate the output. So after generating generating the uh, Bitonic sequence, we have already discussed earlier in the earlier videos that with respect to this Bitonic sequence, it can be passed on as an input towards the stage 4. The stage 4 comprises of the four sub-steps or the 4 sub-stages in which these inputs are being given, and with the help of these increasing comparators, they are being interchanged, and the whole input is getting sorted. So in this way, with respect to the 16 node input, with respect to this 16 node input, we can be able to generate the sorted output with the help of the 4 broad stages. The first broad stage, this is the first broad stage in which we are currently working only 2 elements. Since the logarithm of 2 is equal to 1, so only one Bitonic split takes place, and which has generated those 2 elements into the sorted order. Now, now we are providing as an input towards the 4 elements. Now those 4 elements are being provided as an input towards the um, towards the stage 2. Now the logarithm of 4 is 2. So in this way, there will be 2 Bitonic splits. The dashed line at here is showing the first Bitonic split, and the solid line at here is showing the second Bitonic split. And in this way, we can be able to generate a sorted output. Now, with respect to the next 4 elements and the next 4 elements, there are 8 elements, and the logarithm of 8 is equal to 4 values. So the 3 times the Bitonic split will take place. So it is about the first split, the second split, and the third split which generate the output into the ascending order. And similarly, with respect to the rest of the elements of the sequences, the reverse order list is being generated. Now, in the same way, when these 16 elements are being taken, now the logarithm of 16 is equal to 4. So there are 4 substages, substages in which there are different number of comparators are being used. So the broad stage step 1 has only one substep with respect to the logarithm of 2 or the 1 Bitonic split. The stage 2, the broad stage 2 is having 2 substeps with respect to the Bitonic split of the 4 elements. That is 2. So it is having the columns, two columns at here. Here, the number of the elements that we are currently working are 8. So it has 3 different Bitonic splits, and in this way, it has the 3 columns. Here, in this case, we are working on the 60 elements. So it is the first column, it is the second column, and it is the third column, and it is the fourth column of the sorting network. So in this way, the stage 1 has 1 column, stage 2 has the 2 columns, stage 3 has the 3 columns, and the stage 4 is having the 4 columns. Now this will now this is the same thing that I have explained earlier, that with respect to the stage 1 there is a one column, with respect to the stage 2 there are two different substeps, with respect to the stage 3 there are three substeps, and with respect to the stage 4 there are four steps. Now 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 we should analyze the working of the sorting network. Now, before analyzing the computation complexity of this algorithm, let us recall that in order that into the earlier videos I have explained that a particular sorting network has a number of the columns, and the number of those columns are significant because they determine the depth of the network or the speed of the network, because the speed of the network is directly proportional to the number of the uh, columns, and the number of the columns is being termed as the terminology for the number of the columns is the depth. So the speed of the network is proportional to its depth. uh, so now I shall give an intuitive proof for the for the uh, for the Bitonic sorting network. I shall not give a proper mathematical proof. I shall give an intuitive proof such that you can be able to understand that how the complexity can be determined. So in the so it is the the above figure is the old figure on the previous slides. The stage 1 has only one. uh, Again I shall emphasize the old thing. The stage 1 is only having the one column, the stage 2 is having the two columns, the stage 3 is having the three columns, while the stage 4 is having the four columns. It will help me to uh, to generate the to determine the number of the total depth. So the last stage of an element Bitonic sorting network. So the last stage of an element Bitonic sorting network is working on to the 16 elements, and in this way, four logarithmic of 16 Bitonic splits will take place. So the four times the Bitonic split will take place. So that is why it has the four different columns. So the depth of this particular stage 4 is basically 4. Now, with respect to the stage 3, we are currently working onto the 8 onto the n by 2 elements, at here, and the n by 2 elements at here. We are simultaneously executing n by 2 elements at here, and we are simultaneously executing n by 2 elements at the here. But both of them doesn't overlap with each other. Now, with respect to this n by 2 or 16 by 2, 8 elements are there. The logarithm of 8 gives the value 3. So in this way, the the depth of the stage 3 is 3. Similarly, similarly, uh, similarly into the second stage, similarly we are working onto the n by 4 elements. So 16 by 4 are the 4 elements, and the depth of such a thing is having the is 2, because the 2 times the Bitonic split will take place. So the logarithmic of 4 is equal to 2, and there are two columns with respect to the stage 2. The stage 1 is only having the one column. So in this way, if we will add all of them together, then the total depth of this whole Bitonic sorting network will be 1 plus 2 plus 3 then plus 4. So as I explained earlier, it has the depth 1 with respect to the stage 1, with respect to the stage 2, the depth 2, with respect to the stage 3, the depth 3, and with respect to the stage 4, the depth is 4. So the total depth is 1 plus 2 plus 3 plus 4. So, but if I want to generalize it for any n element input, so it will look like as 1 plus 2 plus 3 plus up to log n, and uh, and this and this looks like sum of n natural numbers, where n is basically the sum of the logarithmic of n natural numbers. So the sum of the logarithmic of n natural numbers is equal to n into n plus 1 upon 2. So replacing n with the logarithmic of n into logarithmic of n plus 1 by 2, we are able to get this particular expression. Since the dominant term at here is the log square n, so it is basically the theta of square n is the complexity of this full process. uh, as as I explained into the previous video, that the binary sorting network is very much efficient in comparison to the sequential sorting algorithm, because it is having the complexity as theta of log square n. But if I will implement the same algorithm into the uh, sequential term, but if I will implement the same algorithm into the sequential sorting methodology, it will not give a better result in comparison to the heap sort and the merge sort, but it will give a poor result, such that its complexity is theta of n log square n. So in this way, we can, so in this way, if we expect that the same type of efficient complexity will be given by the binary sorting network into the sequential implementation, it will not give a better result, but it will give a poor result. Okay. So it is so that it so with respect to the parallel implementation, the complexity is theta of log square n that we observed at here, and with respect to the sequential implementation, the complexity is theta of n log square n. The the reason is that we have to implement each of the comparator sequentially, and here into each stage all of the comparators are executing simultaneously, and that is why the time complexity of the sequential sorting algorithm has become poor in comparison to the best algorithms for the sequential sorting. In this way, I end the present video.